I welcome you all for the third lecture on unit number 4, that is Introduction to Vibrations. In the previous class, we have discussed the addition of harmonic motions, and in today's class, we are going to discuss the addition of harmonic motions analytically and also proving the same results graphically. So let us start with the first problem. Add the following harmonic motions analytically and check the solution graphically. So problem number 1, x1 is equal to 4 cos omega t plus 10 degrees and x2 is equal to 6 sine of omega t plus 60 degrees. So let us start with the solution. Let x1 is equal to 4 cos of omega t plus 10 degrees and x2 is equal to 6 sine of omega t plus 6 degrees. In the previous class, we know that we have discussed the addition of two harmonic motions will result into a harmonic motion only. So let us assume x as the resultant of x1 and x2 and x is equal to a sine of omega t plus alpha. So therefore x becomes x is equal to x1 plus x2. Now x in the equation x is equal to x1 plus x2, substitute the values of x, x1 and x2. So it becomes a sine of omega t plus alpha is equal to 4 cos of omega t plus 10 degrees plus 6 sine of omega t plus 60 degrees. Now expanding on LHS as well as RHS, we know that sine of a plus b is given by sin a into cos b plus cos a into sin b. So accordingly, expanding the equation a sine of omega t plus alpha as a and sine of omega t plus alpha, I am going to write inside the bracket as sine omega t into cos alpha plus cos omega t into sin alpha, which is equal to 4 into cos of omega t plus 10 degrees. I am expanding it as 4 cos of omega t into cos 10 degrees minus 4 sine of omega t into sin 10 degrees plus 6 sine of omega t plus 60 degrees, once again expanding as sine of a plus b. So it becomes 6 sine of omega t into cos 60 degrees plus 6 cos of omega t into sine of 60 degrees. Now taking the coefficients on LHS and RHS, taking the or considering the coefficients of sine omega t and cos omega t on both the sides. So sine of omega t into a cos alpha plus cos of omega t into a sin alpha is equal to sine of omega t into bracket minus 4 sin 10 degrees plus 6 cos 60 degrees plus cos omega t into bracket 4 cos of 10 degrees plus 6 sin of 60 degrees. So substituting the value of sin 10 degrees, cos 60 degrees, cos 10 degrees and sin 60 degrees, we are going to arrive at the equation sine of omega t into a cos alpha plus cos of omega t into a sin alpha is equal to sine of omega t into bracket 2.305 plus cos omega t into bracket 9.135. Now comparing the coefficients of sin omega t and cos omega t on LHS and RHS, we are going to get a cos alpha is equal to 2.305 and a sin alpha is equal to 9.135. I have taken the coefficients of sin omega t on LHS and RHS and coefficients of cos omega t on LHS and RHS. In the LHS, the coefficient of sin omega t is a cos alpha, which is equal to the coefficients of sin omega t on RHS is 2.305 and the coefficient of cos omega t on LHS is a sin alpha on LHS and coefficient of cos omega t on RHS is 9.135. So therefore a is equal to under root of 2.305 whole square plus 9.135 whole square, which is going to give us the result of a as 9.42. Because we know that, or how we have done this value or how we have got this value of a is squaring and adding the a square cos square alpha plus a square sin square alpha is equal to 2.305 whole square plus 9.135 whole square. Taking a square common, so inside the bracket the remaining term is cos square alpha plus sin square alpha, which is equal to 1. So we can get the value of a. So now tan alpha is equal to, we know that the equation for tan is sin by cos. So substituting tan alpha as sin alpha by cos alpha, which is nothing but 9.135 divided by 2.305. So the answer is 3.963. So therefore alpha is equal to tan inverse of 3.963 and alpha is equal to 7.838. So now we can substitute the values of a and alpha into our governing equation here. X is equal to a into sine of omega t plus alpha. By solving or by adding the two harmonic motions, we have got the value of a and we have got the value of alpha here. So the value of a is 9.42 and the value of alpha is 3.75.838. So substitute in the equation x as x is equal to 9.42 into sine of omega t plus 75.838. Now we need to check the values whatever we have obtained by graphical method. We need to prove that whatever the results we have got, it is true. For adding the two motions graphically, let us put two equations as x1 is equal to 6 sine of omega t plus 60 degrees and x2 is given as 4 cos of omega t plus 10 degrees. As x1 is in terms of sine and x2 is in terms of cos, so we need to convert both the equations either in terms of sine or in terms of cos. So because of that, I will convert x2 which is there in terms of cos in terms of sine by adding it 90 degrees. So it becomes, if I add omega t plus 10 degrees, it is there. If I add 90 degrees to it, then it is converted into sine. So it becomes 4 sine of omega t plus 100 degrees. Now first draw OX and OY axis. First draw OX and OY axis and write the equation of x, that is 9.42 into sine of omega t plus 76 degrees or 9.42 into sine of omega t plus 75.838 degrees. Both are correct. First draw the axis OX and then draw the axis OY. Then draw the vector x1 is equal to 6 centimeter at an angle of 60 degrees with OX axis, because we know that the value of x1 is 6 sine of omega t plus 60 degrees. So here the value of a is 6 and the value of alpha is 60 degrees. So at an angle of 60 degrees, draw a 6 centimeter line and mark it as B, and which is nothing but x1. Similarly, draw the vector x2 which is nothing but 4 sine of omega t plus 100 degrees. Then draw a line of 4 centimeter at an angle of 100 degrees and mark it as OD. So we have drawn x1 and x2 now. Now from B, draw a dotted line as shown in the figure from B to C parallel to line OD, and similarly draw a line from D parallel to OB, and wherever both intersect, the point is called as C. So now draw a line from O to C and measure the angle. It will be 76 degrees, and with the help of scale measure the length OC. It will be exactly equal to 9.42. So this completes first problem on addition of harmonic motions. Now let us discuss the second one. So here instead of giving two different equations, they have given a single equation which we need to split into two equations. Split the harmonic motion x is equal to 10 sine of omega t plus pi by 6 into two harmonic motions, one having a phase angle of 0 and other of 45 degrees. Let the equations are x1 is equal to a sine of omega t and x2 is equal to b sine of omega t plus 45 degrees. We know that from the addition of harmonic motions, when we add two harmonic motions, the resultant equation will also be harmonic. So x is equal to x1 plus x2. We know the value of x, that is given 10 sine of omega t plus pi by 6. x1 is nothing but a sine of omega t, and another one is x2 b sine of omega t plus 45 degrees. We have taken plus 45 degrees because they have given one is having a phase angle of 0, so the phase angle for x1 is 0, and other having a phase angle of 45 degrees. So that is x2 is equal to sine of b into sine of omega t plus 45 degrees. Now, as usual, whatever we have done in the previous problem, expand the equations. Sine of omega t plus pi by 6 as sine of a plus b, and here also sine of omega t plus 45 degrees as sine of a plus b, and compare the coefficients on both the sides. You are going to get the equations for a and b and the values for a and b. So we are going to arrive the value for a as 3.67 and the value for b as 7.07. Hence the equations of harmonic motions can be written as x1 we have taken as a sine omega t. So substitute the value of a here. The value of a is 3.67, so it becomes x1 is equal to 3.67 into sine of omega t, and the value of x2 is b sine omega t plus 45 degrees. The value of b is 7.07, so x2 is equal to 7.07 into sine of omega t plus 45 degrees. Now let us discuss the graphical method. Whatever we have solved through analytical method, the same has to be shown through the graphical method also. First, draw the axis OX and OY as shown in the figure. Now draw OA is equal to 10 sine of omega t plus 30 degrees. So it means draw a line of 10 centimeter at an angle of 30 degrees. So its starting point is origin, that is O, and end point is A, that is at a distance of 10 centimeter. Now from the previous equations we know that OA makes an angle of 30 degree with OX. So draw a 10 centimeter line OA at an angle of 30 degrees. Now draw x1 is equal to 3.6 sine omega t along axis OX. The equation x1 makes an phase angle of 0. So at an angle of 0 degrees, draw a 3.6 centimeter line and mark it as B. O to B measures 3.67 centimeters and it is 3.67 omega t and it is x1. Similarly, draw x2 which is given as 7.1 into sine of omega t plus 45 degrees. So at an angle of 45 degrees from O, draw a line of scale 7.07 centimeter at an angle of 45 degrees. So that represents x2. Now from x2 draw a line parallel to OB, and similarly from B draw a dotted line parallel to x2. So wherever they are going to intersect, that is going to give us 10 sine of omega t plus pi by 6. Now from O to A already you have drawn a line, so both will intersect. BA will intersect with this 30 degree line, and hence it has been proved. If you measure the length of OA, it will be 10 centimeter and it will be placed at an angle of 30 degrees. So this completes the problems on addition of harmonic motions. In the next lecture, we'll discuss the remaining concepts of the unit number 4. Thank you.